Hello, hi. My name is Madis Uuemaa. I'm the next presenter. I'm here to present my startup, Smart Load Solutions. And if any one of you is interested in smart grids, is interested in electricity prices, or how utilizing this sort of technology may help with your project, let's say electric heaters, industrial electric consumers, you're very welcome to listen to me. I know that you're all doing your own project, but who is interested, I would have a story to tell you. I have a story to tell you about two engineers, people just like you maybe. One smart home engineer and one industrial automation engineer. And within this story, I would like to also bring out what does the Smart Load Solutions, our small startup, do. So, as said, my name is Madis Uuemaa. I'm a co-founder of Smart Load Solutions. It's a company that's fine-tuning electricity consumption. So, here's the story. We have two automation technicians. One is named Matt. He's a smart home developer, really good at software skills, comes to these events like TechnoHack all the time, has made a lot of projects, knows something about hardware as well, plays piano. Well, you know, your average guy from IT, comes from IT university and is really good at programming. The second automation technician, his name is Vova. He's a father of three, has been working in industry for 20 years, has been programming PLCs, knows about electronics, knows how the factories work. He works in an industrial automation companies and does projects for that. And about their companies as well a little bit. Matt's company is this very innovative smart home company that's making these awesome solutions for their clients. Basically, what they're doing now is they're making that your house is voice command operated. You can say anything to your house, the house will listen. He's the main programmer there. He wants their product to be really good. The people are liking it, they are buying it, their company is doing really well. Now, Vova's company, however, it's an industrial automation company. It goes to from factory to factory, and currently one of their clients is asking for them to renew their manufacturing plant. They want to make it more efficient, and that's why they have contacted Vova's company. Now, one day, these both engineers, they go to a conference, and they hear about this thing called demand response. Although they had heard something before, they now get the idea that electricity prices are known 24 hours ahead. In every hour, there is a different electricity price, and the price fluctuations are quite huge. If you look at this screen, it's an electricity price from this Thursday, and as you can see, the prices fluctuate quite much. The minimum price was 25 euros per megawatt hour, and the maximum price was 70 euros per megawatt hour. And at 1 hour, the price is high, 1 hour, it's quite low. This basically depends on the demand of electricity. When the demand is high, the prices goes high. When the demand is low and there's a lot of power available in the grid, the price is quite low as well. The second thing they notice is that when consumers all consume together and the price skyrockets, the most polluting power plants go on. So they are starting to think, hey, if my customer wouldn't consume during these peak hours, that would mean they would save money, first of all, and they will be really environmentally friendly. Because of them, the most polluting power plants do not have to go on. And they are thinking, hey, this could be really useful for the client. Then they hear that because we have these peak hours, the transmission fees, electricity transmission fees are really high because we need a power grid that is capable of providing this electricity even at the peak hours, even when everybody wants to use electricity. So we have to build these big electricity grids, big power plants, which are always in the reserve, will be used only once or twice a year. and everything is paid by the end customer. And fourth and final, if their customers would act based on these electricity prices, it would be really good on the renewables, because then we can build these renewable power plants, I mean solar plants and wind turbines to everywhere, because the demand will be based on their production. So it will open up doors much better for the renewables as well. So the next day, they both go back to their workplaces, and Matt's thinking, where can I use this technology? And then he thinks, hey, electric heaters, very good place. You can heat the house when the temperature, not the temperature, but the price is low, and when the price is expensive, you can turn off the electric heater, the house doesn't cool down that fast. I can save to my client, and my client will be much more environmentally friendly. The same goes for Vova. He's checking that, hey, there's a water pump in a plant which pumps water into some sort of reservoir. Today it works basically when the reservoir is at minimum level, the pump fills it up, and at the maximum level, the pump stops again. But hey, it could be working based on the prices. At the cheap times, it fills the storage, and at the expensive times, the water will be taken out of this storage. So they are starting to think how to do it, and they are beginning to see a lot of problems there. Like, for example, in the Matt case, he's coming to think, okay, how fast does the temperature in that particular house of his clients actually drop? Or if he turns the heater on, how fast does it rise? Then comes in the weather, like one day it's +10 outside, how does that affect the warmth of the house? Then the other day is -20. So that's a factor he has to take into account. And of course, then again, there's the power of the electric heater in the first place, because one electric heater in one house can heat up the house in 2 hours. In the second house, it might take 5 hours. So it's really hard and complicated for him to think of a way how to most optimize it based on the electricity prices. So same goes for our Vova dude. He's thinking, hey, at what times does that factory consume that water? Because I cannot turn off the pump when the factory needs the water the most. Then the second thing is, of course, efficiency. Would it be better for the pump to work on low load all the time, or at maximum power when the price is cheap, and at minimum power when the price is high? Because this thing depends on startup costs and etc. etc. And of course, then there are the prices which keep on changing all the times, and sometimes the prices can be 5 hours straight very high. At what times do you consume electricity? Again, a problem. And in most cases, they might find a solution, but they will probably stop it because they don't have the time to do it. Matt thinks, I gotta make my clients smart home ready by next week. I do not have time to develop this. Vova thinks, okay, this really has got to work. I cannot allow that the manufacturing plant needs water, and currently there is none because of my solution, and thus he drops the idea again. And this is in the most cases, because we have these lot of flexible consumers out there, but none of them are optimized, because none of the automation technicians has the time to develop these solutions. That's where smart load solutions come in. We have created this demand response platform for these automation companies, that we can provide this electricity consumption shifting times to the companies, very simple, very fast, very cost-effective ways, and without any discomfort or loss of productivity for the end customer whatsoever. So how does it work? What Mats and Vova have to do is they have to connect their electrical devices with our cloud service, and we are able to optimize the work of these electrical devices based on the local electricity prices, on the local weather forecast, and we take into account all the restrictions. So the customer's house will never be cold, or the manufacturing plant will never stop because there was no water in that reservoir. So let's see how does this solution work in real life. First thing they have to do is that they have to log on onto our website, create an account. Then there they have to register their device. On the website there will be, of course, manuals how to do it and etc. etc. But they have to register their device, where we give a unique device ID for every device connected, also access signature. And what they do with it next is they need to have some sort of a hardware at the plant or at the house they want to connect, but both of them are engineers who are exactly doing that, so they can use their own solution. And the first thing they need to do is start sending data to our cloud. And in the case of the electric heater, this data will be the inside room temperature, the outside room temperature, if possible. If not, we will take it on the weather forecast database, and of course the power of the electric heater. And for Vova, he will have to start sending us the data of the water level in the well, if possible again, not needed all the times, to water level in the storage, and of course the power of the pump. From that we will start learning, and learn all the characteristics of the device connected. Now what they need to do if they want to optimize their device is basically they start making requests into our servers. In the request they have to have the local restrictions. For example, in the case of the heater, it's again what is the max power of the heater, what is the desired temperature in the room. It can vary, like during the nighttime it's 80 degrees, during the daytime it's 23 degrees, or whatever the customer wants. And other restrictions as well, I won't go in that on details. In the case of Vova, he will have to send again what's the maximum power of the pump, what is the minimum maximum storage levels, and etc. etc. Now if we get this request, we will automatically calculate for each device when is the most optimum time to work. And that's what we answer to them, at what times with how much power that particular device should work. The third thing, of course, locally they have to make sure that any restrictions aren't breached. Meaning if a client opens all his windows, all his doors, the temperature rapidly drops, we can see it from our server, but we cannot contact the machine, the controller operating that electric heater. So they have to check these themselves, that it wouldn't go into the limits, and if it does, they can make a new request into our server, and we will tell them how to operate now. First get the temperature back to the normal level, and then optimize. Same case on the water level. If it goes to the minimum or maximum, the local controller has to take action. So these simple three things, and we are able to provide the effect that the end consumer has smaller electricity bills, the end consumer is more environmentally friendly, and time and money is saved for those automation technician and smart home technician. And now, when they have connected this, they can see that there are other sorts of consumers as well which they can connect, like in the house water boilers, electric cars. In the industries we have industrial dryers, anything with a storage like wood chippers, even hydropower plants. So there are things that you can shift based on the real-time prices. The thing which we are hoping now is that all the automation technicians, all the smart home technicians, some of you maybe here, will take this solution into account to provide this optimization to the end consumer. So that will bring the effect of demand response on a much larger scale to the society as a whole much faster. Meaning we wouldn't have those peak hours anymore, we wouldn't have to pay those transmission fees so much, we can shut down the most expensive, most polluting gas power plants, and of course we can focus on the renewables. Some little bit about the technology we use as well in our cloud service. First of all, this all is built on a smart grid, on the basis of the smart grid. For example, everyone must have these new, what are those, smart meters? Yeah. So by the year 2017, everyone in Estonia has a smart meter installed. Also, we rely on Internet of Things, that devices get connected to the cloud, otherwise we have no way to optimize them. In our cloud, it is very highly scalable. We can connect hundreds of thousands of devices with our cloud. For every one of them, we create this data storage where we collect their data, and we use machine learning upon it to find the most optimum ways for it to work. Our team includes me. I'm a PhD student of power engineering here at TUT. Our CTO is Mr. Allan Puusepp. He's the one who thought of this idea, who made this cloud possible. He was working before coming to SLS, he was working at Eesti Energia actually, and was optimizing utilities here. That he optimized the way we use, I don't know what's põlevkivi, coal? Oil shale. Yeah, he optimized this whole process from mining it until it gets to be sold as an electricity. And then we have my brother Märt, who is into product development together with Daniel, and we have a sales guy as well. Who we are missing from this team currently is one automation technician, one electronics guy, somebody who is willing to join with our team to start connecting devices to our cloud, so we will get feedback what to change, what to need. We already have these industrial automation companies and smart home companies connecting devices. However, we need somebody on our side as well to help us make this a better product for the end consumer. So if anyone's interested in this, they can come and talk to me later about it. So yeah, that's it currently from me. Thank you.
Okay.
Does anyone have questions?
Okay, yeah, yeah, SymPower is also trying to build the same area machine, but not exactly same, and he has a really good questions.
You'd be happy to hear that we're building a piece of hardware that can eventually maybe connect into your system and be optimized from there. But I had a question about the data requirements. You said you need all of the sort of current temperature, everything to be constantly uploaded into the server. Have you talked to households? Are people happy with the data being shared in that way?
Yeah, definitely. They probably won't be happy. At least some portion won't be happy. However, I believe that things are changing, because a lot of people, they can share the data if they get the benefit of lower electricity bills. Also, of course, we sign an agreement that we do not give any data outside. And third of all, a lot of more important and personalized data is already known about you. So basically, the power of your electric heater, that ain't so personal. So I believe that humanity is shifting in this, that they want a better world, and they are willing to give their data away for that.
Okay, somebody else want to ask something in smart grid topic? Hello? Everybody? I have one question, maybe just one suggestion, maybe that right now you can charge your car maybe when the prices are really slow, but maybe you can add there also one application that you get some SMS that right now the price is lower. So you can drive home really fast and starting to load. It can be just one plus in the software, I mean.
Yeah, absolutely. We can actually, since this is a cloud service, we can later on start to provide these additional services as well.
Yeah,
one,
exactly.
one like you mentioned, the other that SimPower is also doing is that virtual power plant, that if the grid needs, we can turn devices for a short time on or off, and we can actually pay for the end consumer. In the future, from this data, we can build also different services. So that's the idea, that the consumer wouldn't just get cheaper electricity prices, but other potential benefits of the system as well.
Yeah, very good. So, if anybody have some questions? No?
Well,
Okay, then thank you, Madis.
yeah, and if somebody is interested in finding out more, our office is actually down on the Zero Ground, so you can always you can get my contact information there as well. You can come talk to us. We can explain the idea further, explain what and who we are looking for. So come along.
Okay.
Thank you.